Hi, and welcome back to IoT Innovation. Today we talk about the network, the infrastructure, the cost, and all of this data flying around.
This episode of IoT Innovation is sponsored by Anritsu.
Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
Hi, and welcome back to IoT Innovation. My name is Chris Hare, and today I'm joined by Morgan Kurk of Commscope, and he is the Senior Vice President of the wireless business. So first of all, Morgan, welcome, and thanks for joining me for a chat about IoT. But partly I'm interested to maybe start with a conversation about Commscope and tell us a little bit about the company, tell us what you're involved in IoT, and then we can dig a bit deeper into that.
Well, thank you. I appreciate being here today. IoT, what an interesting subject. I like to think about it as just a continuation of the industry that I've been in for the last 20 plus years, which is the wireless industry. And I guess you have to go back a little ways to kind of understand some of the convergence of factors that are going on that create the Internet of Things. Wireless operators have been growing for the last 20 or 30 years, originating first with cell phones that really just were used for voice conversations, that started in business and then moved toward the consumer base. Once that happened, that was 1G and 2G. 3G became a methodology to start with data. The original data app was actually a short message, and a short message, to a certain extent, is something akin to much of what the Internet of Things will be like. And now it's expanded.
A happy accident, right? SMS in its first case.
SMS was an accident, and a very happy one financially for the carriers, but also for the consumers. Mm-hmm. It opened a whole new way of communication that we just simply didn't do before, and really has proliferated throughout society now that a lot of communication, whether it's a direct SMS or the offshoots of SMS like Snapchat or other things, have really they've taken hold and been embedded in society. After SMS, though, it was sort of, how do we use data? Well, data for email was sort of the first real data app, and now today you have the full Internet on your mobiles. Where this comes back to is the carriers now are looking to continue to grow subscribership. Year over year, they've determined that they can't charge too much more per subscriber, so the only way for them to grow is to gain more subscribers. You can see this because I'm sure, look at your cell phone bill, and you look at your cell phone bill now or what it was a decade ago, and if anything, you saw it go down, not go up. So we're now at about 7 billion subscribers in the world. Many people having more than one device, maybe a tablet as well as a cell phone, or a laptop as well as a cell phone. And we're looking for other ways of utilizing the networks and other ways of improving the networks to make that utilization easier. And that's sort of where 5G comes in. And 5G is one of the enabling things that will allow the Internet of Things to exist. And before we get into what 5G is or what it isn't or what it may be, and we really don't know yet because it's under discussion of how it will be done, you have to consider, what are you trying to solve for the Internet of Things? So I classify it into a couple of different areas. You're going to have lots of devices in the Internet of Things that have very low data rate and are not very important to be sent out immediately. Right. Very similar to SMS, actually. Something like a soda machine, transmitting that it needs more of one flavor of soda cans. That being attached to the Internet is a good application of the Internet of Things, or your refrigerator.
But its time and its latency is not really critical.
That's right. So you have very, very low bandwidth, and whether it appears a minute after it's been informed is not relevant. So it has to be very, very low. And these devices as well are attached to the wall with power. The second set of types of IoT devices, they're going to be very similar constraints, low bandwidth, not immediate reaction necessary, but not connected to anything else. So you can imagine this as a temperature sensor in part of your house. I call them lick 'em and stick 'em devices.
Right.
And these are devices that need to communicate for long, long periods of time. They may have batteries in them. They may have solar collectors in them. They may have motion collectors in them, some way of storing a finite amount of energy. And they need to be able to communicate. So you
these
need
are things that we're starting to see, like iBeacons and similar devices that have got 2-year battery lives, right?
Exactly. And they could have much longer devices, or they could have much longer battery lives if they were much more efficient about how they transmit data. That's going to be one area that needs to be worked on for 5G. Then you have a class of devices that might be high data rate and high latency needs. And so I'll give you an example, or excuse me, low latency needs. I'll give you an example of that. Imagine an ambulance that actually had robotic arms in it controlled by a doctor somewhere else. That network to actually control those robotic arms would have to be very, very fast, have no latency, because if you were going to do a surgery in the field, you certainly don't want to say, well, cut down and I got to wait for it to stop. So you have those types of applications as well as just other devices that are going on. So they all fall into these categories of, do I need of energy? How much energy can I consume? What sort of latency can I have? And what sort of bandwidth do I need? And that drives us to a whole bunch of different network needs. So a really good network would be capable of all of these things. And if it wasn't capable of all of these things, then you would have to build separate networks to solve these problems. So I'll give you an example of separate networks. Imagine you had a two-way paging network. This is a very, very narrow bandwidth channel. It covers everywhere, absolutely everywhere, very, very low data rate, and pretty efficient in terms of power. That could be one way of applying this Internet of Things for that type of a class. You have the current network that we have today, which has reasonably low latency, not where it needs to be, but quite good bandwidth and bandwidth that's increasing. That could be another one of these. But if I look forward, and what I believe will happen is I think we will end up with only one network. However, it may involve a multi-protocol network, something that is able to adapt, be defined by the bearer service it needs to have. So you can imagine as you're transmitting data, if the data is high definition video, you have a lot of periods of time where you're checking to see if the data that is being sent actually arrived there correctly. And it's long amounts of data, so this checking, which is called overhead, doesn't take up much bandwidth compared to the payload. You could think of another type of data, which is a very short message, 10 bytes, my light needs to be turned off, or my light is off. A few bytes back and forth. If you use the same amount of error correction or ensuring that the data actually got sent, you're going to use up a huge amount of bandwidth for these now, what will be billions of devices that will be on there. So I think there'll be a convergence of networks, but I think there'll be many protocols that will have to operate on those networks to satisfy the energy requirements of some devices, the latency requirements of some devices, and the bandwidths of some devices.
So talking a little bit more about the networks, I mean, we've talked in terms of fast lanes and slow lanes over the last few weeks. I guess one of my concerns is, does this create, just when the FCC is busily turning the internet into a utility, doesn't this turn this into a non-utility and end up having haves and have-nots? I guess, you know, building on the comment you made about having one path, one stream, I guess the answer is no. But don't you see the need for fast traffic and slow traffic, high data rates, low data rates, depending not on the device, but what people are prepared to pay for them?
Yeah, so this is the constant battle, and it's the same battle that we have today with the carriers fight out today. A couple of years ago, when they were really looking for subscribers, in some areas you had unlimited data access. Didn't matter what data rate you had, you got unlimited data. Today, when people enable VoLTE networks, voice over LTE, those actually have higher priority than data. Since the time that people have allowed unlimited buckets of data, those plans have rolled to high-speed data for a period of time and then low-speed data after you've used up a certain amount of data. So I think in both fairness and in a way of forcing people to use data appropriately, there are going to be various applications that require higher bandwidth, and they're going to be given higher bandwidth, and they may be charged accordingly. There are going to be different other applications where you get to choose, and other applications where low data and it's sort of best use, you get a discount for. Sort of similar to, well, you can even liken some of it to the power grid today. Right. If you're willing to turn off your power usage during peak times, you get a much lower rate during other times.
Okay.
So that going on.
I can see that really a way of saying it rather than haves and have-nots. I guess my concern is that the more affluent countries, companies, and individuals are going to have access to a faster rate of traffic. Yeah. I mean, I certainly understand the class difference between devices. Some devices just don't need the full bandwidth, and some do. It just seems like the potential for abuse is high. But anyway, moving on a little bit, one of the things that I looked at when I started wandering around Commscope's website was to understand a little more about the storage situation. One of the things that family members say to me quite often is, oh, well, it's okay, all of our data's in the cloud. And when you kind of quiz them a little bit about what is this cloud, where is it, what is it doing, they really have no concept. And from that point of view, that all of this stuff has got to be stored in some rural location somewhere in the world. And, you know, don't we get to the point where we end up with a mass of server farms around the world that are storing data that is of very limited use to people? Or how do we kind of right-size the balance between what we save and what we don't?
Sure. So Commscope is an infrastructure provider, right, primarily in the physical layer. So we make the things that move data around. We make the structures on towers. We make antennas and cabling and fiber and all the things that connect data, that allow the data. So you can imagine us as we're the highway of the data world.
Right.
But that's an interesting topic of where data is and what needs to be saved and what gets thrown away and how much storage is too much storage. I guess Moore's law is still in effect. So data becomes much cheaper every minute that you wait. But all data is not equal, and it's going to get even less equal. And you talked about haves and have-nots. Architectures are going to change. So if you look back at the history of computing, you had, in the beginning of computing, you had things called mainframes. And mainframes have dumb terminals. And dumb terminals were simply direct connections to the mainframes where you couldn't do anything without being connected via cable. Then you went through a microcomputer era where most of your data was stored locally and most of your processing took place locally. We're now swinging back, and this is a constantly oscillating event that moves much of the data to a centralized location. In this case, you're saying server farms. Well, all this is enabled by the speed at which you can access these things. So if processing power costs a lot, you tend to centralize it, as long as the speed at which it takes to get to that centralized location is fast enough. So we'll be going back and forth between this, and some advances, particularly in memory, that we see coming out are going to change how data is stored, we think. There will still be massive farms, data farms, but there will also be far more local data farms, edge data farms, and even on-device data storage.
Right.
And all of it will be a balance of what data is needed at what time. And I have a great example of this. Consider mapping data. It is most likely that you're going to need mapping data wherever you are. So the 10 blocks around you may actually be constantly stored and updated on your device, and you may have virtually instant access to it. The neighborhood that you're in may have a server near a cell site, or at the cell site, or at a cluster of cell sites that would service that area, and that data, that local data with your information on it, because you were close, would be stored right there. Then for a larger city, there'd be a centralized place to the larger city, and then ultimately for a country, there'd be a centralized place for a country, and so on and so forth. So all these things are changing, and where Commscope really helps with all of this is enabling those paths to be minimized in the amount of time it takes to go between those points, either via microwave or via, which is a wireless backhaul, which is actually faster than fiber, or by a fiber backhaul, or by creating the actual small localized data centers, the buildings and the cabling in them and the structure that goes on with it, or working with our OEM customers and partners to do things on the tower to enable a faster access to a lot of that data. Then going to your question about how much is too much. It's the same sort of answer that you get before. It's too much when we determine that we're going to charge people if they exceed a certain limit. So today, storing data personally is virtually without cost, right. Or very, very low cost. There's almost no limit on it. But if that number gets too high, companies will start charging for it, and they'll charge something like it, and it's a self-correcting problem. If you go back to your question about the haves and the have-nots, I actually think technology is moving very quickly, so there will be better and there will be worse. But even in poorer regions, the economics that are driven by the richer regions or the richer consumers or the richer companies, however you want to put it, will ultimately not just trickle down, but will gush down to a lot of the rest of the world or the country or the other folks. And I see this as a great equalizer.
Yeah, I think equalizer is right. I mean, I following that thought a little bit. I mean, I've mentioned before in other episodes that we've done where we've talked about business models like mobile payments, where you actually get the equalization taking place in both directions. So you get business models driven and applications and services driven by developing countries that don't have the same infrastructure and therefore have to consume bandwidth much more efficiently than in some of the developed world. And certainly I see this having a big impact on IoT, because these little devices that you describe, the nodes, the lick'em and stick'ems, I think they're going to have to be very, very efficient, not just in processor usage and memory usage and battery usage, but just in cost and footprint. You know, I've bought iBeacon style devices over the last couple of years for projects that we've been working on, and they've gone from, you know, $100, $200 each to almost throwaway costs that you
absolutely
literally stick them on a wall and forget they're even there until one of them sends you a message that the batteries run out 2 years later. Yep. So coming on from that a little bit, I mean, one of the angles that I've been really fascinated in with IoT over the last couple of years is distributed computing. And I think, you know, when you talk about going from the consumer device being the smartphone or the wearable that's connected through to the network infrastructure via the towers, the antenna and structures and design, right through to storage, I think there's almost like, I don't know if you ever saw the movie Inner Space, where they, you know, basically it's a space movie about going inside the body and swimming around inside the molecules and the blood inside the body. I'm seeing distributed computing being just the same kind of scenario. Is this the type of area that you see that as I feel, is rampant with opportunity for developing technology? Actually sharing very small amounts of data, very small amounts of offloaded processor power to these lick'em and stick'em devices?
Yeah, so a lot of this will come down to not just the cost, but really the energy concerns behind this. And I'll give you an example of an area where you would think that more would have happened, but it really doesn't, or really hasn't yet. And that's in having device-to-device communication that helps make the network more resilient. So some sort of a mesh, which is in effect what you're discussing.
Yes.
And by and large, there have been a few applications where this is done, but by and large, this has not had a great take rate yet. And my belief is that it's really because we are still severely limited on battery, on power.
Yes.
And until that is solved, the idea that you would let somebody use effectively your battery when that is the precious resource, not your computing power, nobody cares about that, your battery that would then not be available for you later on or would require you to recharge it earlier than you would have thought, is really, it's the inhibitor. Right. Now, there are lots of new battery technologies that are being discussed, talked about. anything from making current technology significantly cheaper. I'm sure you've heard of Tesla's Gigafactory,
Yes.
to some of the breakthroughs that they continually come up with, which are solid state type batteries, or aluminum-based batteries, or nano-based batteries. So there's a lot of work going on in this area, so I have hope that will happen in the future. However, I also must caution everybody, lithium-ion was invented in about 1991 because tape decks were going away and Sony had extra capacity. And this was the invention that came out of it. But if you look at that, you have to go back. I mean, batteries were essentially the same for the previous decade.
Right.
Lead-acid batteries have been stable for a very long time. So it's really going to require some breakthroughs in size, energy density to really make this happen. And I think there's hope of that, because energy storage is not just important for this. Energy storage is so important for energy in general, for renewables. So I think that will have to happen before a lot of these devices become meshable. The things that can be meshable today, or anything that's fixed that has its own power, and we've seen some of this with the open computing projects that go on.
Right.
Because processing power is the thing you actually don't care about there. If I'm not using it, why do I care if somebody else is? And then you have the security layer that has to go on top of it, which has to be worked, but that's solvable.
Yeah, I think absolutely. I mean, we in some of the consulting we're doing, we're dividing the world into devices that are plugged into the wall and devices that aren't.
Yep.
And largely that division is about the available battery or lack of available battery power. And as a result, whether that scarce resource is something you really care about using for something else, I think that's right on the money. So coming into that from the indoor perspective, one of the challenges that I'm seeing, not just professionally but personally, is that as much as we're making huge strides in connectivity and uptime, both personally and professionally, when I'm out and about and traveling and around the world, I'm still fighting the challenge indoors, in my home, in offices, in buildings, with network connectivity. What are you seeing in terms of advancements in this area? Because I still feel that connected via my own Wi-Fi, where I'm paying for Wi-Fi via my cable TV company to supplement my mobile phone provider that doesn't have a good enough signal locally, that I know I'm being screwed over, and that's not fun. And
Yep.
really rather figure out how to get off the idea of needing a home phone, where I'm out and about, making sure that I've got in-building coverage, I've got in-building GPS, I've got all the services that I expect when I'm walking down the street in these buildings. And what are you seeing in these areas?
Yeah, so it is a really big area for the wireless operators today, and it continues to grow. It's an area which Commscope is extremely active in. It's one of our larger businesses.
Right.
I think the answer is it actually is a challenge. Operators have the following challenges in building out the network. There are really only three of them. Site acquisition, finding places to put equipment. Backhaul, figuring out how to get the data from that equipment into the core network. And power, getting power to it. Well, in a building, power is pretty easy, and backhaul is pretty easy, whether it's in your home or whether it's in an office. And they're a little different. I'll explain that in a minute. But if you can imagine, in your home or in the office, those two things are very, very easy for a wireless operator to do, albeit it may be expensive to put in a system. But the biggest problem in covering all of these places indoors is really getting acquisition to it, and how hard it is to get consumers, or more often office space folks, to allow the wireless carriers to come in and install equipment on premise to deliver those services. So what the industry is working on, and what we specifically have been working on, we now have systems, wireless systems, that look and act and feel exactly like a Wi-Fi access point, a server, and a switch, and can be installed, operated, optimized exactly by the same IT people that take care of the rest of the infrastructure that's in that building. And what I see is sort of a convergence of needs. you, like every other person who is in a building, have a great desire for having ubiquitous, high-speed coverage. The wireless operators have a real desire to have you get off the macro network. You're sucking capacity out of that macro network that they can't afford to be sucked out of.
Yeah.
And the building owner has every interest in satisfying his tenants. So these three things we believe are converging and will allow the wireless operator to make available the spectrum, the building owner to allow access, and the occupant to add probably money, but if not resources, to make those systems economical and thus deliver this sort of ubiquitous, very high-speed, future-proof network that we're going to need to do the things of the future. I agree with you. I have not had a home telephone in 20 years. Mm-hmm. I almost can't conceive of one. Right. Because what would the number be? It would have to be my cell phone number. That's how people reach me. Right. So that's definitely coming. And in the office, it's that we have to get to the point of guaranteed service. And until VoLTE or high definition voice, cell phone calls were not of the same quality as a landline, but they were far more convenient. Right. I think we've reached the point in the quality scale, which actually cell phone calls can be of a higher quality than landline.
Definitely.
The speaker phones can be at least as good as speaker phones. The mobility aspect of something that you absolutely, it's the killer thing. Mm-hmm. Just being able to have anybody call you or anybody interact with you at any time because everything is moving with you is really why everything is going that way. That too, however, continues to have the one problem we spoke to before, the same thing that plagues the Internet of Things, and that's power. And I am one of those people that predict that in the future, devices that you carry with you will be charged from afar, will be charged wirelessly.
Yeah.
We're not talking about being charged from hundreds of kilometers. We're talking about being charged from some point on your ceiling to wherever you are in your office or room, and having energy beamed through the air so that the idea of at night charging your device or plugging a device in to our children will be just as foreign as a record player is today.
Yeah, having just switched over to a wirelessly charging smartphone, I agree. I don't want to go back to plugging it in anymore. Yeah. And it's making quite a difference already.
And the one that you have today is simply something you still have to put on a desk.
Absolutely, no, it's a baby step, but I think it's a step in the right direction, as you say.
Absolutely, and when you can always have that with you,
yeah,
when you never have to take that away, the wearables become unbelievably valuable. The idea that you'll have a larger projection screen from a camera, from glasses, or that you'll look at your hand and it'll project onto your hand. There are lots of other things that can be done if we solve the energy problem. It's one of the things that I think will keep us going till 2030 and beyond.
Yeah, one of the guests we're going to have in a couple of weeks is actually one of the battery manufacturers, so I'm looking forward to exploring that with them.
Fantastic.
So with that, Morgan, I want to end it there, please, and say thank you very much indeed to Morgan Kurk of Commscope for joining me today. It's been a really interesting discussion about the infrastructure and the developments that we're going to have over the next few years. Hopefully, we're going to see the improvements of it in a fairly short space of time. I think regulation and cost are going to be some of the issues that are going to face the rollout broadly, but nonetheless, I think it's going to be interesting times. So with that, thanks again, Morgan, and look forward to joining you again next week on IoT Innovation.
IoT Innovation is a production of RCR TV. To reach Chris Hare or suggest a show topic for IoT Innovation, you can reach Chris at cbh@ntete.com. To find out more about IoT Innovation and all things wireless, visit rcrwireless.com.